This is a quick video to show how to do a couple of the problems from 6.4. This is where we mix all of the transformations for linear and exponential functions together. Lots of different problems here. We start off with the linear function f of x equals x, and then they just want you to write down what the new function would be given these type of transformations, and then we'll take a look at a few others. So it says reflect this over the y-axis and then up 4 units. So if we were to reflect this over the y-axis, I'm just going to draw a little axis right here. So this is what y equals x looks like, what f of x equals x looks like. And we're going to reflect this across the y-axis. The y-axis would be right here. So what we'd be doing is we'd flipping the left for the right and the right for the left. So it's going to end up going like that. When we do this, when we change this over the y-axis, we're flipping this horizontally. We're flipping over here. So what happens is we're going to take this and we're going to take the x and we're going to multiply it by a negative. And I'm going to do that inside parentheses because we did this as a horizontal change. And then we want to move it up 4 units. So we're going to write a plus 4 right there. Now, that right there is a perfectly good way to write it. If you wanted to write this with a slightly simplified version, because this is a horizontal flip, there's not a huge difference between that and a vertical flip when we're talking about linear functions. So if you wanted to write it as y equals negative x plus 4, either one of those would be totally okay. This is kind of what they meant. But again, because this is such a simple transformation, either one of those would be okay. Let's slide down here and take a look at another one. Let's take a look at number 13 here. So on number 13, we've got a reflection over the x-axis this time, and we've got this parent graph of an exponential g of x equals 5 to the x. So it says reflect this over the x-axis and then down 1 unit. Well, remember, if we're going to reflect this across the x-axis, let's draw what a general old exponential would look like. It's going to look something like this. If we reflect it across the x-axis, so here's the x-axis, what we're going to do is we're going to flip everything that's on the top and we're going to flip it on the bottom. So it's going to look like this. It's a vertical flip, so that's a vertical change. So what's going to happen here is we're going to multiply the function, whatever that was, by a negative. So this is going to be negative 5 to the x. And then vertical shifts are really easy. If we just want to move this down 1 unit, literally all we have to do is just write minus 1. And that's it. That's all we have to do on that one. Let's flip over to the second page. Here we've got some to graph. We've got some linear ones. We've got some exponential ones. I'm going to choose this one right here. I'm going to do number 18. This one is a linear one, but it's got a couple things going on here. So it says describe the transformation, then graph it, and then label at least 3 key points. So let's make sure that we do that. So on this one, we're taking y equals x, or f of x equals x, that plain old standard parent graph of any linear function. And here's what's going to happen. We're going to make it half as tall. So we're going to write vertical shrink, and I'll write half as tall, okay? Or we could write half as steep. Either way would be fine there. The plus 3 with the x, remember with the x, if you change it before it makes the shape, if you're changing inside the parentheses there, it actually moves it in the opposite direction. So this is going to move it to the left 3 units. And this is a vertical change because it's outside the parentheses. This is actually going to move it down 1. So we're going to take the standard shape that looks like this, and what we're going to do is we're going to make it half as tall. So that means we're going to have something like this. I'm going to change these to blue. Okay, so let's say that's the original one. Now we're going to take this and we're going to make them half as tall. So we're going to stay right here. This one would be half as tall, so instead of going over 1 and up 1, we're going to go over 1 and up a half. Back 1 and down a half. So we've got the shape of this linear graph that looks like this right here, not quite as steep. And then we're going to move it to the left 3 and down 1. So we're going to go over 1, 2, 3, and then we're going to go down 1. So we're going to be right here. Okay, so that's kind of where the center is again, and then to make this shape, we go over 1 and up half as far as we normally would. We're going to go back 1 and go down half as far as we normally would, and this is what the graph would look like. So again, if we've got a straight edge, that can be really helpful, so I'm just going to draw a line about like that. Okay, now we've got a couple of other things going on here, so let's make sure we label this. That point right there was, and if I have to draw a line, I will. So this is going to be negative 3 comma negative 1. It used to be at 0, 0, but remember we moved it left 3 and then down 1. That one right there, that's going to be at negative 4 comma down 1 and another half, so down 3 halves. So we'll write minus 3 halves. And then this one right here, that one's going to be at negative 2 comma We went back 2 and down a half. So this is going to be negative 1/2. So we've described it, we've graphed it, we've labeled it and all that sort of stuff. And one last thing, again, this isn't required, but what we could do is we could come through here and we could say, take a look at this. This is the original one. Does it look like it's half as tall, and does it look like we slid it over 3 units and then down 1? Hopefully it does. And again, when you're dealing with linear functions and some of these transformations, it's kind of hard to tell the difference between, one type of transformation, maybe a horizontal slide and a vertical slide or something like that. But that will be enough to suffice on these problems here. All right, good luck with these practice problems. They're really good. Need lots of practice with these. Good luck.